debacle. Okay. I took the plunge. I pressed the record. Now you get to hear that when you watch this. Okay. 4.3 trigonometric ratios. This is where it starts getting a little more difficult. So there are the primary trig ratios. Sine theta is y over r, which remember it was opposite over hypotenuse, but opposite is always y on a circle. Hypotenuse is always r on a circle. Cosine is x over r because adjacent over hypotenuse. So x is adjacent, r is hypotenuse, and then tan is y over x. And remember I said tan, we could always do y over x because y is sine and x is cos, remember, off your unit circle. So for points on the unit circle, r is always 1. We said that yesterday. Awesome. The marker isn't working. Yay. Oh. Now. Oh, you're going to hear my laughing. That's terrible. Oh. Okay. Let's try again. Woo! There we go. So for points on the unit circle, r equals 1. Therefore, the primary trig ratios can be expressed as sine theta equals y, cos theta equals x, and tan theta equals y over x. And it's y over 1 because your radius is 1. It's x over 1 because your radius is 1. So that is why sine is actually y and cos is x on your unit circle. Thanks, Nathan. I mean Schmathan. So we hide who you are. Okay. Since cos simplifies to x and sine simplifies to y, you can write the coordinates of p theta as cos theta sine theta, which we went over yesterday. This is where it becomes new, and I don't remember if you guys were showing it last year because you're the APs, but cosecant is 1 over sine. So all that would do is you'd take whatever sine is and it would flip, right? It would become the reciprocal. So instead of y over r, cosecant is r over y. Secant is the opposite of cos, so 1 over cos. So it would be r over x. And then cotan is 1 over tan, so it would be y or x over y instead of y over x. Just they flip, right? They're the reciprocals of each. So the easiest way that I remember it is cotan goes with tan, not rocket science. They both have tan in them. And secant goes with, S goes with C and C goes with S. So S does never go with S and C does never go with C. So don't say cosecant and cos. It doesn't happen. They don't like each other. They're not friends. Okay. So recall from the cast rule that sine theta and cosecant theta are positive in quadrants 1 and 2. Remember that you guys know cast, C-A-S-T, right? Well, sine, the reciprocal of sine is cosecant. So cosecant follows the same rules as sine. If sine is positive in 2 and 1, cosecant is positive in 2 and 1. If tan is positive in quadrant 3 and 1, then cotan is also positive in quadrant 3 and 1. And if cos is positive in quadrant 4 and 1, then what goes with cos? Secant, because cos and cosecant don't go together because they both start with C's. Okay? So it's not like you have to remember another like cast rule with the cosecants, cotans, and secants. They follow their reciprocal identities. Okay, I'm going to get you to flip ahead actually to page 4. We will come back. So we're going to do example 3 and 4 first. I know it's a little unorthodox, but we are. Example 3 and 4 are very similar to what we did yesterday. You're going to tell me the exact value. The instant it says exact value, it can't be a decimal. Also, exact value is kind of a hint that you're probably going to be pulling it off the unit circle, right? Because the unit circle, we have all those lovely exact values. If you plug tan pi over 2 in radian mode into your calculator, it's going to give you a decimal. That is not exact value. That is not what they are looking for. But if we go tan pi over 2 and we have our unit circle memorized, because we're doing it every single day, every single day, every single day, tan is just what over what? Because our unit circle only gives us sines and coses, right? So what's tan, even off your formula sheet? Bryant? I mean B-Dog? Sine over cos. So at pi over 2, what sign at pi over 2? Yeah. You got ahead of yourself. What sign at pi over 2? Sign is? Over. So you're right. It's undefined because you can't divide by 0. Cosecant of 7 pi over 6. So 7 pi over 6 is the same as 210 degrees, right? Because you'd go 7 times 180 divided by 6. Or if you have your unit circle written out, 7 pi over 6 falls on it. Okay? Cosecant is the same as 1 over sine of 7 pi over 6, right? Or cosecant of 7 pi over 6 is the reciprocal of sine of 7 pi over 6, right? So sine of 7 pi over 6 is what? Off your unit circle. So sine of 7 pi over 6. Yeah. Negative a half. So then cosecant would be negative 2. Yeah. Because this is technically 1 over negative a half, which is the same as 1 times negative 2 over 1. So it's negative 2. Sine of negative 300. If I drew negative 300, it would be 60 short of the x-axis because this is negative 360 and this is negative 270. What coterminal angle on the unit circle would match negative 300? What coterminal angle? Yeah, 60. So technically we have 60 degrees here. They want sine of 60. Sine of negative 300 is sine of 60. What is it? Yeah. Root 3 over 2, because we're looking for the answer, right? Yeah, pi over 3 is right for 60 for radians, but the answer is root 3 over 2. So whenever they give us sine of the angle, they want the answer from the coordinates. If they gave you sine theta equals one of the coordinates, then they'd want the angle. So it's just difference of what they give you, which we'll be doing soon. Secant of 60 is 1 over cos of 60. So basically, it's whatever cos is at 60, the reciprocal, right? So what's cos at 60? 1 over 2. So it would be 2, because it would be 1 over 2, which is 2. Because when you divide by a half, it's like multiplying by 2 over 1. Okay, cos of 150. So if I go to 150, I'm going to point to you. If I go to 150, what would you get for cos? Negative root 3 over 2? Yeah. Because cos is the x-coordinate. Sine of 315. Yep. Sine of negative 30. So sine of negative 30 is coterminal with what angle? Good job. 330 degrees. So I want sine of 330, which is? Negative 1/2. Tan of 240. Tan of 240. Tan is what over what? Is y over x. Sine over cos, y over x. So at 240, it's going to be negative root 3 over 2 divided by negative a half, which is negative root 3 over 2 times 2 over 1, or negative 2 over 1. The 2's can cancel. The positive, negative times a negative is a positive. So it's just root 3. Tan of 480. What is tan of 480 coterminal with? Tan of 120, because we're going to go around and then here. So tan of 120 is root 3 over 2 divided by a negative root 3 over 2, right? Nope, 3 over 2 divided by negative a half. So that's root 3 over 2 times negative 2 over 1. The 2's cancel, so it's just negative root 3. And then for f, I told you we go through it together. Somewhere along the line, someone thought it would be fun to put a square in between the cos and 225, which messes people up because they're like, I don't know what that means. All that means is cos 225 degrees squared. And you're going to have to change it to that every single time in calculus, because when you go to do a derivative in calculus, you have to have the squared out because you're going to drop it in front when you do derivatives, which you don't know right now. But that's what you're going to do in calculus. So cos 225 is the x value at 225, which is negative root 2 over 2. And then we're going to square that. Negative squared is positive. Root 2 squared is 2. 2 squared is 4, so it's actually a half. You're right. And go. Okay, so tan of 7 pi over 6, we can change that to degrees if we want, but if you've done the unit circle, it's just on it, right? So you don't actually have to change it, but you can. So you're going to times by 180 over pi. The pi's cancel. 7 times 180 divided by 6 is 210. So we want tan of 210. Tan is sine divided by cos, or y divided by x. So it's negative a half divided by negative root 3 over 2, which is negative a half times 2 over root 3. Now this is the catch. It's negative 1 over root 3, which is lovely. But most of the time, the denominators are rationalized, which means no radicals, right? How do I get rid of a radical in the bottom? Well, the only way I can get rid of the root 3 is if I times it by root 3. Because what's root 3 times root 3? 3, because root 3 times root 3 is root 9, which is 3. So whenever you want to get rid of a radical, you have to multiply this by itself. The catch is you can't just randomly multiply a denominator by something. You'll completely change the answer, right? If I type this in now and I want negative 1 divided by 3, that is not the same answer as negative 1 over root 3, right? So what I do to the bottom, I have to do to the top. So I'm actually going to get negative root 3 over 3. Now, if I typed in negative 1 over root 3 in my calculator, and I typed in negative root 3 over 3 in my calculator. Oh, poo, it's on the top, isn't it? No, it's not. It's just positive. Good chance that... All right, we're back. Okay. 2 positive, 2 negatives make a positive. Okay, root 3 over 3. Yay. Okay. Just for comic relief, I'm pretty sure I'll put this one up. Okay, sine of negative pi. So negative pi brings me to where? Here. Sine at negative 180, the coterminal to negative 180 is positive 180, right? So sine is 0 because it's your y value. And then we want tan of 2 pi over 3 squared. 2 pi over 3 is root 3 over 2 divided by negative a half. So that's root 3 over 2 times negative 2 over 1, which is negative root 3. Then you have to square it, of course. Which is negative 3. Oh, which is so much prettier, which is positive because you square a negative. Oh, lovely. Okay. All right. The only one I want you guys to go over on this one technically is, remember I said to you guys yesterday, if you're given secant 85.4 and they want these to 4 decimal places, what's the 2 things you have to remember? 1, it has to be in what mode? Degree, because you're putting in a degree. 2, there's no button for secant. So what do I have to do? What's secant the reciprocal of? Cos. So it's going to be 1 over cos 85.4 degrees. So we did this yesterday, which is 12.4690. Okay, then flip back to example 1. Yeah. Okay, so given the following point on the terminal arm of some rotational angle, find the exact value. Exact value means not decimal. For all 6 trig ratios. So that's sine, cos, tan, cosecant, secant, cotan. You have to find it for all 6. When you're given a point in trig, the very first thing you should do is plot it. Draw it. Put it on the Cartesian plane. Oh, look at that. Plot the coordinates and sketch the angle. So that's the first thing we're going to do. And I'm going to do it over here because we have to put all the different trig ratios. So it's actually going to be a tight fit. So our coordinate is at, the point is at -2, -6. And I try and draw it a little bit accurately because it will help you out. So we plot our point -2, -6, and our terminal arm goes through it, is what it says. Okay. In order to do all 6 trig ratios, I have to have x, I have to have y, and I have to have r, correct? Right now I have x and I have y, but how am I going to get r? Well, I can draw this as a triangle. You always draw it towards the x-axis, you guys, because you're always going to be doing the reference angle, and the reference angle is a little angle towards the x-axis. Okay? I always say when you draw your triangles, every single time, it should make a bow tie, depending on which triangle you're drawing. If you're trying to do it like this, that's a really weird bow tie. Don't do it. Stop yourself. Okay? So you always draw towards the x-axis. Then we label what we know. We know x is -2. This is really squishy. We know y equals -6. How can we find r? Anyone? Okay, so we're going to use Pythagorean Theorem. We're going to have r squared equals -2 squared plus -6 squared. So r squared equals 4 plus 36, which is 40. Then when we square root, we have to remember to always put what in front of our square root when we take the square root of something? Positive and negative. The radius is a distance. Distance is always what? Positive or negative? Positive. So our radius is always positive. Our x value can be negative. It is. Our y value can be negative. Our x value can be positive. Our y value can be positive. But our radius is always positive. Now, going back to grade 10, root 40. I'm just going to do it up here because I don't have a ton of room. We know it's going to be positive because it's the radius. The radius is always positive. Root 40, we have to reduce radical. Root 40 is correct. However, that answer won't be on your diploma. Root 40, I can break down into what perfect square? Root 4 times root 10, right? Root 4 times root 10 is root 40, correct? Why would I break it down into that? Because root 4 is a perfect square, and root 4 is 2. So instead of writing root 40, which is correct but won't be there, I'm going to write 2 root 10. So my radius is 2 root 10. So I can go back here and I can say r equals 2 root 10. So that's lovely. If I want to write out any type of trig ratio, given a point, you always draw your triangle, find all the sides, and then you can go and do your trig ratio. Okay? Rarely will they ask you for the trig ratio of the numbers they gave you. They're going to make you find the third side. Okay? So they usually ask for sines or coses or secants or cosecants because it's going to force you to have to find that third side. Okay? So let's try out the trig ratios. Sine theta is what over what? Y over r. You know sine and cos are both something over r, right? Someone once told me they memorized it by sign your resume. It works. And she had other ones too, but I can't remember the other ones. But it was like sign your resume. Hey, it works. Or sine equals y over r. You know, options. So y is negative 6 over r, which is 2 root 10. Shh. What is my catch? Yeah, what's my other catch? Radical in the denominator. So I'm going to go up here and do it. Negative 3 over root 10 is what it's going to become, right? Because I'm going to take a 2 out of both. Then I'm going to multiply by root 10 over root 10. So I actually get negative 3 root 10 over 10. Cos theta is x over r. So negative 2 over 2 root 10, which when you reduce it is actually going to be negative 1 root 10 over 10. Tan theta is y over r. This one's nice because it doesn't have the root. So negative 6 over negative 2, y over x, sorry guys. Negative 6 over negative 2, or 3. Now, once you have all three of those, the reciprocal ratios are easy because they're literally the reciprocal ratios. So whatever sine is, cosecant is flipped. Whatever cos is, secant is flipped. Now, what some people do for sine, you guys, is we reduced it to negative 3 over root 10, correct? But people will go to here and they'll write 10 over negative root 3 over root 10, and then they'll have to rationalize it again. So if I'm going to cosecant, I want to use this one or the one before it, or the one after, I guess, negative 3 over root 10. Why would I want to use that one to flip instead of my answer to flip? Yeah? Then you don't have to rationalize. So if I do cosecant theta, oops, I'm going to get root 10 over 3, negative 3, or negative root 10 over 3, because I like having the negative on the top personally. Cos is secant. And I'm going to use the negative 1 over root 10 version, because when I flip it, it's negative root 10, yeah? No, if you use the later one, you'll get the same answer, but you're going to have to rationalize, so it'll just be more work. But you'd get the same. You'll just end up having to cancel off stuff after you've even rationalized. So secant is going to be root 10 over negative 1, or negative root 10. And then cotan theta, instead of it being 3, it would be 1/3, because 3 is the same as 1 over, or 3 over 1. When I flip it, is 1/3. You guys try number 2. Okay, so we plot the point at 3 and -4. We plot the point at 3 and -4. We draw our terminal arm through it, and we drop towards the x-axis. So we have -4 and we have 3. We use Pythagorean Theorem, so r squared equals -4 squared plus 3 squared. So r squared equals 25, 16 plus 9. Square root, plus or minus, but because it's r, it has to be positive 5. You'll see 3, 4, 5 triangles a lot. 3, 4, 5 triangles come up a lot, which is nice ones if you see, because then they don't have radicals. Okay, so sine theta is y over r, or -4 over 5. Cos theta is x over r, so 3 over 5. And tan theta is y over x, or sine over cos, so -4 over 3. Then cosecant theta is just the reciprocal of sine. So instead of -4 over 5, it's -5 over 4. Secant theta, instead of 3 over 5, it's going to be 5 over 3. And cotan theta is going to be -5 over 4. Okay? So on your tests, they can give you a point and ask you for any trig ratio, right? They can ask you for 1, 2, 3, whatever they want. Often they can give ones with the radicals because then you have to do a little more work, right? Okay, flip to example 2. So they can give it to you as a point, which I find people do a lot better at. Or they can give it to you as a trig ratio. All right. So if they give it to you as a coordinate, people usually spot it, say it's a point, plot the point, and they're good, right? However, if I give it to you like this, tan theta equals 4/5, people are like, that's beautiful. I like it. I don't know what to do with it, but I really like it. Yeah. Tan is what over what? Yeah. Y over x. So here they actually gave you the exact same thing as last time. They just didn't write it as a point, right? The x is 5, the y is 4. This way, though, they have to tell you what quadrant it's in. Why do they have to tell you that it's in quadrant 1? Because it could be in quadrant 3. Because if these were both negative, what would end up happening when I actually made it to be tan of something? You would cancel those negatives out. You would never write -4 over -5, right? So it could be in quadrant 3. So they have to specify, because of cast rule, tan can be positive in quadrant 3 and 1, so they have to tell us what quadrant, or they have to restrict the domain of what theta can be. So it's in quadrant 1, so we're going to draw it. It's the first thing we're always going to do. We're going to draw it. It's at 4 and 5. So 5 along the x, 4 along the y. Draw my arm through it just like I did before. Draw it down. So my x is 5, my y is 4, and I'm going to solve for the third side. Now, with these, though, it's not always that you're solving for r. They could give you r, right? If they give me sine of something, or cos of something, or secant of something, or cosecant of something, it's going to be y or x over r. So you'll have to solve for the other x or y that's missing. Okay? When it's a point, you're always solving for r because they always only give you x and y. So for this one, we're solving for r because they gave us x and y. We had tan. So r squared equals 4 squared plus 5 squared. This table is basically doing the steps for you. Like, find out what quadrant, draw the diagram, solve for the third side, give me the remaining ratios. So r squared equals 16 plus 25. So r squared equals 41. Square root, plus or minus, but because it's r, it's just positive. Root 41 is a prime number. You're not reducing it to anything. It just stays that pretty. So I go back and I label my diagram so I have everything over here. R equals root 41. And for myself, I also say x equals 5, y equals 4. Because then when I go to do my trig ratios, I don't oops and grab the wrong one. Okay? So given the trig ratios in the quadrant of a particular rotational angle, find the other trig ratios. Okay? So we have tan. We're going to need sine theta. Sine theta is y over r. So it's going to be 4 over root 41. Rationalize the denominator, so multiply by root 41 over root 41. And you're going to get 4 root 41 over 41. What goes with sine? What's its reciprocal trig ratio? Cosecant. So I'm going to do it next just because I want to. Cosecant is r over y. So if I use this one, I'm going to have to rationalize it, right? Because I'm going to flip it. The root 41 is going to go to the bottom. So I'm going to use the first one, the 4 and the root 41. And I'm going to write it out as root 41 over 4. And the denominator is rationalized already. Yay. If you run into number 2, not the end of the world. There's lots of things. If you want, you can write it down too. Okay. Cos theta is x over y. So it's going to be 5 over root 41. Rationalizing the denominator, you're going to multiply by root 41 over root 41. So you're going to get 5 root 41 over 41. What goes with cos is secant. And secant is going to be root 41 over 5 because I'm just going to flip it. And then cotan theta, it's a really tiny little box to fit all that in. Cotan theta, go back to tan. Tan is 4 over 5, so cotan is going to be 5 over 4. We're going to go to number 3. So number 2, let's just look at for a second. This would be y over r, and we would draw it in which quadrant? What is 90 to 180? 2. So you'd be drawing it in quadrant 2. That's what that means. What does this mean? So everyone's usually good with this. They're really good with quadrant 1. You just draw it in quadrant 1. When I give you tan is greater than 0, people are like, you knew. I don't know which one. Whenever it says tan is greater than 0, that's a fancy way of saying tan is positive. There are only 2 quadrants where tan is positive. Here and here. So then I get the fight. Well, that's 2. I need 1. Which one do I use? Yeah. Why? We use 4 because we go back here and we say sine is negative. And which of these 2 is where sine is negative? Well, sine is negative in quadrant 4 and quadrant 3. Where's my double up arm? 3. So that's the one I'm going to use. Did you say 4? 3. You said sine was negative. Yes, you were right. Technically. So it's in quadrant 3 because that's where our arms double up. Here I have a single arm, here I have a single arm, so I'm not going to use those ones. So you have to use the trig ratio and the sine. All right. So I draw it here. Sine is what over what? Y over r. This is where people get tricked out. They sometimes write it like this. Sine theta equals 2 over negative 3. Then people say, well, okay, the radius is negative 3, and they write it. What did I tell you? The radius is always positive. So even if they make the radius negative, that negative sign can go in front. It could move to the top. it could move to the bottom. That negative sign can go anywhere, right? So just because they put it there doesn't mean that should be where it should be. What should be negative? Y or R? Y, because R can't be. So I move that negative sign up with Y, and this goes away, which makes sense because my Y needs to be negative to be in this quadrant, correct? So my Y is -2, my R is 3, and I need to find my X. So Y equals -2, R equals 3, and I need to find my X using Pythagorean Theorem. X squared equals R squared minus Y squared, just by rearranging the formula, because I'm going to move my Y over with the R by subtracting it. So I get X squared equals 3 squared minus -2 squared. So X squared equals 9 minus 4. So X squared equals 5, and X equals, because I square root, plus or minus, X equals plus or minus 5. Now with radius, it was easy. It had to be positive. With this one, this is the reason why you draw the diagram. It's not, it's root 5. This is why you draw the diagram. Because if you draw the diagram, this is my X length. Is this negative when I go to my X to here, or is it positive when I go to my X to here? Yeah, negative. So my X is actually equal to negative root 5. So that's why drawing them is very important. So you know what quadrant it is, so you don't mess up and not take the negative sign or the positive sign, depending on where it is. Now we can do our trig ratios. Sign's already done, so I can do cosecant. You can take up the box on top. It doesn't matter because we're not going to go back to it. So cosecant is x over r. And this is a negative. It doesn't look like it. So x over r. Or sorry, cosecant is opposite of sine. So it's the reciprocal of sine. So instead of 2 over -3, it's going to be -3 over 2. Then we have cos theta. Cos is x over r. X is negative root 5 over r, which is 3. Now if I do secant, there is no fancy way to flip this so that I don't have to rationalize. Because x is the radical, I'm going to have to. So I'm going to go -3 just because I like putting the negative on the bottom over root 5. Rationalize my denominator, root 5 over root 5. And I get -3 root 5 over 5. What do I have left? Tan and cotan. You can run into the next one, doesn't matter. This is what we're doing. Tan theta equals y over x, or -2 over negative root 5. It's going to become positive because tan is positive in that quadrant. Multiply by root 5 over root 5 to rationalize it. So you're going to get 2 root 5 over 5. And then cotan is going to be what? Root 5 over 2. I'm going to flip this one. You can flip this one. You're just going to have to do more rationalizing. So I'm going to flip the first one. So 2 over root 5, when it's the reciprocal of it, it's root 5 over 2. So you can do page 201, 1 to 3, 5 to 7, and 9.